Okay, hi, I'm Lorraine, and I am here to do an example problem for you about half life. So here's the question. The question is, if a tree dies and the trunk remains undisturbed for 1.360 times 10 to the fourth years, what percentage of the original C14 carbon 14 is still present? We are given the half life of carbon 14 as 5,730 years. So, when I do half life problems, I start with a chart. And you can see the chart here. It has 4 columns and as many rows as we need. We are going to label our chart. We are going to have the first column as number of half lives. We are going to have our second column be time. We are going to have the third column as mass. And we are going to have the fourth column as percentage. Because in half life problems, we can actually solve for any one of these items. Okay. In this chart, some things are going to remain constant and the same no matter what you're solving for. So I'm going to put those in now, and I'm going to put them in red so that we know what is always going to be the same. So we always start with 0 half-lives. Then we have 1 half-life, then 2 half-lives, then 3 half-lives. Okay? And after that, the thing that is another item that remains the same is our time. Our time is always going to start with 0. The last thing that is always going to be the same is going to be our percentages. We are always going to start with 100%. After 1 half-life, it goes down by half. So then half of 100 is 50. It goes down by half again. So we're taking half of 50 this time, not half of 100, half of what we just finished. So we have 50, half of 50 is 25. What's half of 25? Because every time it goes down by half, 12.5. Okay, so the percentages can continue on for as many half lives as we have. And in this example, maybe we need more, maybe we don't, but this is where we're going to stop. Now we're going to shift to using the actual question. So the actual question is talking about carbon 14. And in the example question, it tells us that the half life of carbon 14, 1 half life, is going to be 5,730 years. Okay, that's 1 half life. 2 half lives is going to be 5,730 years. So 2 half lives are going to be 11,460. Okay. 3 half lives is going to be 1 more of that 5,730 years. So we're not doubling 11,000. We did double 5,730 to get to 11,000, but that's because it was 2 half lives. That's where the doubling comes in. If we're moving on to 3 half lives, then we need to take that 5,730 and multiply it by 3, or add another 5,730 to the 11,000. And that is going to be 17,190. Now, they don't ask us anything about the mass here, so we can leave it blank. We can come back and I will talk about that if that's something we need. The half-life depends on the isotope. So for carbon 14, again, it's 5,730. But if I was talking about another isotope like iodine 131, it's 8 days. And so it's really dependent. That time is dependent on what we're dealing with. So The example that we have tells us we have, let me go to this. The amount of time is we have 1.360 times 10 to the fourth. And so we have to also know what scientific notation is. And so scientific notation is something that we would go over in a different example. But what we have is that all of our time is in standard notation. So we have to change our standard notation into scientific notation. And so we need to know where our decimal is. Our decimal is over here. So we're going to move it 1, 2, 3 positions. 1, 2, 3, 4 positions. 1, 2, 3, 4 positions. So we have 1.3 times 60 falling between half-life 2 and half-life 3. So the percentage that is left is between 25 and 12.5. And so when I do these problems, I don't go in between. I say, okay, I have less than 12 or less than 25, and I have more than 12.5. If the question is asking for an exact number, then I would figure that out. But at this point, for me, it is suffice to say that we have 12.5 because it is more than two half lives and there is no real in between.